Welcome to Session 7, where we will explore the cutting-edge innovations that are revolutionizing the mining industry. This session is dedicated to the critical theme of revolutionizing mining industry operational models with new technologies, focusing on innovative solutions that enhance production and energy efficiency in mineral processing. As we gather today, we stand at the forefront of a transformative era in mining, driven by advancements in technology and a commitment to sustainability. The presentations you will hear reflect the industry's dedication to embracing new operational models that not only improve efficiency, but also minimize environmental impact.
Okay, hi everyone, good afternoon, and well done for making it in after lunch. Welcome to the session which is entitled Revolutionizing the Mining Industry Operational Models Through New Technologies. And to provide some additional pretext for this session, we can say that as the mining industry and the mining sector continues to evolve, the integration of advanced technologies ultimately will be critical in addressing some of the industry's key challenges, and those ranging from operational efficiency through to environmental sustainability. So in this session, we will explore some of the key innovations that are contributing to the advancement of mining operations across several of the key technical disciplines. So our speakers are going to cover topics such as improving energy efficiency in mineral processing, advancing mechanical mining technologies, optimizing of transportation systems through the use of automation, and implementing more sustainable mineral extraction methods. We'll also gain some insight into how long-standing industry expertise continues to help drive forward progress in areas such as mining, mineral processing, energy, and ecological responsibility. So I'm looking forward to the talks, the panel discussions that will follow, and thanks everyone in advance for your participation. So the first speaker I'm going to introduce is Esko Takhola from Seadra Minerals Processing.
Thank you, Rob. Ladies and gentlemen, I'm Esko Takhola from Seadra Minerals Processing, an American company providing innovative solutions for mining industries. So, Seadra is behind two measurement technologies that are seen as the best available technologies for mineral processes, so sonar flow monitoring technology and cyclone track particle size measurement. And now we are also introducing to the market the step change separation technology P29. Seadra is a private company coming from Connecticut, USA, and it's very strong in R&D, over 700 patents, and also very strong in bringing new solutions to the markets. So the passive sonar monitoring, flow monitoring technology is been on the market already 20 years. This one seems not to work properly. Can you help me to get it moving faster? Okay. So it's a passive clamp-on. Passive means it doesn't send anything. It has multiple measurement capability, and compared to the old solutions, it's measuring the propagation velocity of turbulences that carry the solids forward. So it's measuring the solids propagation, so their production, while the older methods were measuring the flow of carrier water. And those old systems are not detecting the flow segregation phenomena, so you will have many occasions where the segregation is causing even line blockages, and then you are losing production times. Further on, the material properties do not affect at all to this measurement result, and it's full bore measurement and it doesn't need any maintenance. We have customers that have utilized it already for 20 years, still the same device working with the original performance, and customers have changed the pipe under it due to wear 10 times already in some cases. Installation is very simple. Sensor mat you wrap around the pipe, very light structure even for big pipes, and very good remote diagnostic capability. You can take electrical copies and send them to download them to us for analysis, and based on that we can solve your process problems there, because we get lots of information on the flow stability there and the process, how it's operating because of this technology. Here you see the difference compared to the old technology. With sonar, there is similar meters at the both ends of the 3-kilometer long line here, and this is the difference between those two measurement points. So if you control with sonar your process, you will have less variability in your process. Once again, stuck with this. Okay, already 700 concentrators are utilizing this technology, and for example, 70% of world copper is produced using Sonatracks. The second technology we have brought to the market is the real-time particle size measurement from the overflow pipe of every single hydrocyclone in a battery. Based on that, you can measure a good portion directly. The old technology was to take samples of the consolidated flow of the cyclone battery and bring that to an analyzer, and based on that define what is the particle size distribution. Additionally, you need some equipment monitoring roping detection systems to monitor if the cyclones are operating properly. Now we are directly measuring 5 to 10% of your production in real time. You can follow 5 different particle size limits in real time, and based on that optimize your grinding to be optimal for the following separation stage, which is typically flotation or even leaching. This measurement is based on a waveguide that we put into the falling flow of particles, and particles hit that waveguide, and that impact generated acoustics is calibrated into particle size. Thus you can squeeze the particle size distribution and ensure that every cyclone in the battery is operating properly and providing the optimal particle size for the next stage. And of course, immediately, if one of those cyclones goes to produce off-grade product, you can separate that and make corrective actions, replace it with a better hydrocyclone. Here you see typical data, what we get out of this, so we can follow the performance histories of each single hydrocyclone there. We can see the use rates of these ones, and we can have the trends of all of these, and then of course calculate also the PAD values and follow up that. Here we see how the control based on PST has prevented 5 different roping events in a battery within 40 minutes. With these kind of roping events are not possible to detect based on these sampling analyzers, because the effect of one roping cyclone in a battery is so small that it doesn't affect the average what you are getting too much. So based on this, we can control the grinding circuit, and it means that we can do control to a trade between throughput and recovery. Because if we are grinding coarser, we are increasing the throughput, But if you try and grind too coarse, then you start to lose too much in recovery. So based on our measurement, we can find a compromise that produces the maximum net metal production for that process line, optimize both the recovery and throughput. Typically, our customers have reached from 2 to 10% increases in net metal production based on this. Here, a case study from Kennecott Utah Copper. So they run same process for 6 months with same control targets and compared the PST control to their previous control, and the result was 10% increase in a production in dollars, 60 million per year. So the mill classification circuit is really the process area where the greatest potential of increasing net metal throughput is. So we provide individual cyclones controls and the macro control, which is the grind circuit control, to maximize the net metal production. Secondary benefits are that we prevent the roping events and reduce the grinding energy consumption per ton produced, and reduce water usage slightly. And there is lots of new insight into the process and reduce the variability. And reduction of pebbles into flotation cells, so you don't have to clean them and lose production time for that. Then the Sidra P29 process. The P29 name comes from the atomic number of copper, which is 29, and P from process. So it was developed in cooperation with the copper producers, but applies to all minerals. We are using in P29 as collection media a reusable foam mineral sponge that captures the wanted minerals. And it's able to catch up wanted materials up to 2 millimeter particle sizes. So that's a big difference compared to flotation technology. It frees up thus grind circuit capacity, and it enables increased plant throughput through that. It significantly decreases the energy per unit ton of feed, and it produces also a coarse tail for better water recovery from tailings and more stable tailings dam constructions. So we can, based on this technology, optimize separately the capture of wanted materials, the transportation of them, and the release of them. So the sponge is capturing those wanted minerals easily, and it's efficient gangue removal, and we can do very active and vigorous wash to get the loaded media out for the mineral removal and the concentrate. And then this barren media is rotated back to capture new minerals. The release agent is also recycled there, and it's biodegradable also. The porosity of the sponges is also a factor that we are using to optimize the capturing of different particle sizes into this. So we get high attraction forces, and the tag of polymer enables really vigorous washing and for gangue rejection. So we have high upgrade ratios and low mass recoveries. You can see that even very small amounts of wanted materials in big particles are still captured by this technology. And with these contactor stages, we can have separate of several of them in series, and based on that, those how many you are using, you can tune the recovery to the wanted level. And you can see from this picture, so this orange line there below, that even after that ninth contactor round, the upgrade ratio is still over 4, so this outgoing material is having 4 times more of valuable materials than the feed to that stage. So you can tune your recovery to wanted level based on the steps. Here we see some pictures of how the minerals have been captured to this sponge. There is the simplified P29 process flow sheet. So we do have the coarse feed there, and then we do have contactors, which basically are just rotating drums. And then we wash the gang out of it, and it goes to the next contactor stage, and so on. There's a row of them, and from all of those contactor stages, the loaded media goes then to a gathering unit, and then the mineral recovery circuit is there simply by pumping it forward. So the pump is vigorous enough to separate with the release agent use this wanted mineral out of that, and then you can take the concentrate further. All equipment that are used in this process are already commonly utilized in the process industry, so in mining, even in mining industry. Otherwise, the system as a concept is in level that we are now commissioning the first mine level pilot case. The coarse particle size recovery after a power mill circulating load saves lots of energy, or you can use that to increase the throughput. So here you see that you can save even up to 50% in grind specific energy, or when you take this material, coarse material out to be processed by P29, and then you can increase the production rate with the corresponding amount of materials in the coarse feed. P29 produces also coarse tailings, and that helps you to recover better the water from the tailings. It means that you typically can increase the recovery up to 40%, which is very good for the water balances of mines. Here, typical flow sheet for brownfield cases. So we are taking the coarse material on the underflow and process it with P29. With greenfield applications, we can actually go without mills, because crushing uses only 20–25% of the energy of milling, and with those nowadays we can get down to 6 millimeters. So after that you need only 1 HPGR mill, energy efficient also, and then you can screen the coming result to the P29 process. Or alternatively, you can go and replace just your rougher flotation there in the process. So we are, by P29, enabling grinding with larger particle size, and it can increase the throughput of an existing grinding circuit by 20–40%. It's energy efficient solutions. It enables efficient recoveries from very low mineral exposures. It means also that lower ore contents could be utilized with this technology. And it improves the throughput and economics of existing mines without costs of new grinding circuits. It's fast process, over 90% recovery is reached in less than 3 minutes process time. Thank you.
Perfect timing there, Esko. Yeah, many thanks for sharing those interesting insights in the new technologies in the minerals recovery space. So our next speaker is Bartolome Widra from Komatsu Mining Technology, and he'll be talking about mechanical mining technologies in hard rock mines.
Thank you very much, Robert, for the introduction. I have a pleasure to represent Komatsu Mining. This is mining part of Komatsu Group, which is quite big right now after acquisition of Joy Global by Komatsu 4 or 5 years ago. Komatsu became to be a global player for open and underground mining. And being a global player, it is always a good thing it is a good source of information from different mines, different minerals, different stages of mine development and different technologies. And there is a second stage, very important for such a company. This is like in case of new project for the new mines, is to have enough money to spend into new technologies in order to bring some added value for the mining industry, especially that we are living from the mining industry. And this, what I would like to present you, is just 3 major technologies, especially the newest one, which we developed since 20 years as a Joy Global in Australia, is mechanical cutting of the hard rock. And the last one, which will be the 4th one, which is very recently presented in MINEX in Vegas 4 weeks ago. This is tunneling boring machine for the mines. It is definitely dedicated for bigger mine, but as a technology is quite interesting to be presented. Just 2 words. All this, what is here is the shape of existing Komatsu Group. We have a full range of the surface product, which are well known worldwide. We have Montabed, which is our arm for breaker and drifters, which we are selling all over the world. We have underground Joy Global product, and we have, of course, for big mines, P&H equipment. In general, this what we are observing practically everywhere is that the mining conditions became to be more and more difficult. We are deeper and deeper in every mine. Our conditions for mines are also very challenging, especially the temperature, the height of the seams. So the mines expect that we'll bring something what can help to reduce the cost, to save health of the people working at the heading, and this is something what I would like to present a little bit. As you know it much better than me. There is plenty of mining method if you are talking about the hard rock mining. I will not go deep to each mining method because you know them better than me. But we have tried to find a tool which will be somehow common, which can use and which can eliminate blasting and finally can eliminate people from the top, from the heading, especially from the preparation work, but also for development, but also for production, and also answer for the major challenges coming from the underground hard rock mining, like challenging environmental conditions, decreasing rate of the minerals. I can give some example out of it. There is expectation that the mine will develop faster than originally planned. Problems with labor. It is not easy to find the workers who wants to work with temperature 35, 40 degrees at the mine. Even for 4 hours, we are facing these problems, for example, in Poland. And again, the most deposits are going deeper and deeper, so it doesn't matter which continent we are talking about. And this is a kind of answer for this question, for these challenges. This is the technology which we called mechanical mining of the hard rock. It is sometimes known under the name Dynacut. I hope that I can run this video. Oh, yes. This is machine who is using completely different technologies than all the others. We are cutting the rock by the oscillating disc. It means this is not a rod header. This is nothing to do with shearers. This is disc which is cutting depending on the lithology of the rock with cutting depth of 15 millimeters to 40 centimeters. This is definitely machine dedicated to the hard rock. and mainly for development work, but also for the construction, for the tunneling. This technology was developed, as I mentioned, 20 years ago. This was the beginning in Australia. And over the last 10, 15 years, there was a lot of tests. I will show some picture from the test. I will show you a little bit technology, how does it really work, because this is animation, but these are real machines working at the mines. And this was a kind of investment. It means your companies are investing to document, to develop deposit. We also need to invest to develop technology. We need to find pioneers who want to cooperate with us. When we'll make the test of this machine, not everyone is ready to do that. So we have found some who will later on share or make profits being pioneers in technology. But at the end of the day, we need to find someone who will introduce this for the regular basis. And finally, it takes us more or less 20 years. So this is also showing this case that there is no miracles in mining. This is just a nice video. I just not want to make you sleepy today after the lunch. Just showing the major role of the rock breaking, why we can cut with lower energy consumption on a different method that normally. And this is the secret. This is the oscillating this, and we are cutting the hard rock by this disc. So let me share you with some tests. Unfortunately, there is no sound, but this is example on the 100 MPa monzonite in our testing rig in Australia, in Wollongong. This machine can cut, depending on the material, from I think 2.5 cubic meter per hour up to 15-20, depending on the material. We are talking about extremely hard rock with 300 MPa. Typical example, Canada, Vale mine, Vale Gerson mine, which is extremely hard rock. And on the opposite side, if you are talking about the proper lithology, like in condition of KGHM, which is a split of two different grades of material, it is dolomite and sandstone, the efficiency will be 10 to 15 times bigger. The good thing is that this machine can be used in every mining method. Used in the hard rock, it doesn't matter, we are talking about room and pillar or block caving, whatever. This is really something which is a rule breaker for technology. These are just some picture. I will not describe case by case, but this is the history of our test. We develop in Canada, in Australia, in majority of the cases, in tunneling, in developing works. So definitely, at this moment of time in Europe, we are talking with one customer who has a big potential, very convenient lithology of the rock at the mine to implement first one or two machines. And this will totally remove drill and blast from operation, it means, and remove people. So we are putting the parameter of the machine when we type which way we should cut the rock, which is not always the same. This is the individual profile depending on the rock conditions, and we are putting the parameters which direction the machine should follow if we are still online or we are not in line. So these are just a couple of samples. Machine can operate from 50 MPa up to 300 MPa. This was the hardest material which was tested. So definitely this is the first step for changes, and we think that we'll find the followers who really want to test and use this technology, not only for mining, but also for tunneling. These are just a couple of examples from the tunnel which was made by this machine. So the quality of the side walls and the roof and of the bottom is quite okay. Very easy for further maintain. There is no reason for any further scaling. And if necessary, of course, not on the machine, but as a second stage, it can be also bolted if necessary. The second product group are bolter miner, continuous miner. This is typical product which exists on the market, I think, since 20 years ago. We deliver so far more than 150 machines to different mines in the world. This is mainly dedicated for the softer material up to 100 MPa, typically for example, for minerals like rock salt, polyhalite, trona gypsum, and others like shale oil, which is cutting, can be remotely controlled and very easy to operate with low operation cost. And in case of bolter miners, it can also bolt. So more or less, this is the technology which is very open use with quite wide of product range, depending on the company requirements. Our strongest machine, which operate in the polyhalite, for example, in UK, in Cleveland Potash, or another mines can cut, if the haulage is properly efficient, up to sometimes 2 million tons per year. So it is quite a good figure. Definitely not a machine for the smaller mine, just opposite to Dynaminer, to MC51, but as a very good tool later on. And I had on a very big interest the question of particle size distribution after this machine. In case of this, we have a cutting depth of more than 60 centimeter, and we have very strong limitation of smaller fraction, 0.90 microns, which are a little bit in many mines very questionable. Sometimes we are making compacting, sometimes the mines are making backup filling to avoid the small particles. About the bolter miners, of course, we have two types. Anti-driver, when we are starting to open the deposit. Usually we are making 50-20 meters by classic method, drill and blast. When we assemble the entry driver, which is preparing the first headings, the first chamber, which are necessary to operate regularly the mine, and which is very, very useful for the development. We deliver all type of this machine with more than 100 units per year. Again, this is not a machine for very hard rock. This is for medium hardness of the rock. And finally, I put some figure as advantages. I don't want to go through. Every case is individual. Very difficult to find two similar mines, even if are located on the same deposit. But definitely there are certain advantages, especially if we are talking about the mass production. The first machine was a little bit more flexible for the smaller mine. This one definitely is dedicated for the mines which needs to have a big production, big volumes. And there are a lot of them in Europe and also all over the world. And I'm looking, I have just 2 minutes. I just want to show you the newest baby, which was brought by Komatsu. I have just one picture. This is not animation. This is micro TBM, which was developed by our Japanese colleagues in Tokyo. The first machine is under construction, was presented in MINEX in Vegas 4 weeks ago. And this is basically prepared for preparation work. And it's completely different than this, what is produced by the European producer. It can make a turn left and right, has enough capacity, is much more flexible. And if there is a customer who needs, for example, I give one example, KGHM in Poland needs to build 50 kilometers of the development headings per year. We are talking about such kind of volume. This is really a big size. This machine is absolutely for them. Of course, this is the first unit which will be installed in Codelco in Chile within the next year. But this is also showing some trend which is quite easy to be observed at the mine. If you have very, very valuable mineral, gold, nickel, rare minerals, you don't need to mine million tons. Usually the mine to be effective is starting from 100 to maybe 500,000 tons per year. But if it is required either by the content of metal or mineral per ore or by local condition, the mine needs to mine millions. This is definitely technology for the bigger mines. And making a very short summary, due to the fact that we are a global company, we are definitely listening to our customer. It doesn't matter if we are talking about Estonia with shale oil on limestone, if we are talking about Canada and Sudbury area, when there is plenty of different polymetallic from small to big mines, mainly small, or we are talking about huge mine in Chile or South Africa and in Australia. The good thing, we can show this experience for machine construction. We are big enough to invest into new technologies, which is also important. And we can implement into newest technologies, so in newest application. And this is what we are also representing. We have European presence. We have 2 plants in Europe working for this business. We have 24-hour service. And this is what we always present. We are looking for the time, is end of my time. We are usually cooperating very closely with the customer. It doesn't matter we are talking about development of the new mine, or we are talking about the existing customer who has some problems to overcome to be more efficient, to be more safe, and to bring the more money for the shareholders. Thank you very much.
Okay, thank you, Bart. A great overview of some new and saving or cost and saving efficiencies in the underground mining equipment space. Next up, we have Hinek Kavar, and he's from Ferret, head of the Chinese division, and he'll be talking about dispatch in mining transport and some advancement there.
Okay, just first check. So good afternoon, ladies and gentlemen. Robert, thank you for the introduction. My name is Hinek, and I'm from the Ferret company. I've approached this presentation a little bit different than my colleagues before. I'm not going to present the Ferret company, but I would like to talk about a problem or topic which I have been dealing with customers or other various entities for more than 2 years, and that's dispatching of mine transportation. Ferret company, we specialize in R&D and production of transportation vehicles for mines, be it overground or underground mines. And our specialty is in the mines with danger of explosion of methane. But this is only like one of the things that makes it harder to make dispatch of the locomotives in underground mines with danger of methane explosion. The thing I wanted to talk about is how the dispatching of mining transportation can help the operations in the underground mines and boost the effectivity and help to save or increase the safety of the mining operations in the underground mines. Let's begin by acknowledging a fundamental truth in our industry, and it is that effective transportation and dispatching is the backbone of efficient mining operations. I have written there one quote from Peter Drucker, and that's: the efficiency is doing the things right, and effectiveness is doing the right things. And this is exactly what dispatching and transportation in mine is about, because we have to do the right things at the right time, and dispatching, like having everything in control at one place, is one thing that can help us to do this. In my presentation, I would like to just briefly touch 4 topics, and that's what challenges we have in the mining transportation, to understand the complexities of and obstacles we face on a daily basis in the underground mines, the role of automation, because honestly speaking, I think that except of electric vehicles for underground, that autonomous driving and dispatching is the only way forward, and this is the way where everyone will develop in the future, and that will help the effectiveness of the mining the best. Of course, you might be also asking why me, as the head of Chinese division, is speaking about dispatching of mining transportation. And it's because most of the requirements and things they need to develop comes from China. They are the country which comes to us and they say, okay, we need this one and we need that one. And they are the one who drive us forward together. We don't have such inquiries from the, let's say, European mines, even though there are just a few coal mines in Europe anymore. but they are driving us forward with development together, and I'm talking with them as I have the responsibility for the Chinese market, and we are dealing with these things together. And the core goal and the core reason why they want to develop the things further is that they want to avoid any human error. All of the things which happen underground usually are forced by the human error. Either it is that the drivers are not driving the machines correctly, or that they forget to do some maintenance, and so on and so on. So the safety enhancements are also one thing I would like to discuss a little bit later. And then really this is just a touching topic, is the future trends in dispatching of mining transportation, because this is a topic we could here discuss for hours and hours, and we will probably not get to any conclusion because it's developing so fast. The importance of dispatching in mining transportation, it is a pivotal role in mining transportation, and it is serving as a central nerve of all of the operations in the mines. You know, you are now in Prague, and we have a Prague orchestra, and you can imagine when you go to orchestra, if the musicians play without the conductor, then the music is not very good, you know. So it's the same with the coordination. Dispatching centralizes all of the communication and information between the mine sites, between all of the equipment which is going and working underground, and also between the personals which work underground. And it ensures that all components work in harmony and in a way that it is scheduled and synchronized, and all the resources, be it material resources or human resources, are allocated efficiently. During or because of this, it's extremely efficient booster, because, you know, idle equipment or downtime are very costly, and our colleagues before have spoken about that the costs are increasing, and that we need to find a way how to make it more cost effective to do everything, because otherwise it will be not having a good future. And effectiveness in dispatching optimizes equipment usage. It reduces these idle times and improves turnaround. For example, if we effectively schedule the work of our loaders or locomotives and so on, we can maximize the amount of material which is transported in one shift. And you can, of course, think about that this has a direct impact on productivity and profitability. And of course, I have talked about this before, there is one big pressure on safety. When you have dispatching of the transportation, you can avoid sending the people to areas where you have potential danger of any hazard which can cause any injuries or fatal accidents. So it enables you to monitor and control everything underground, and therefore you can make decisions before they even occur. Without efficient dispatching, mining operations would face significant delays, and this will, again, increase the operational costs and higher safety risk. It's not just about moving material from place A to B, but it is about moving this material from place A to B in the most efficient, safe, and cost-effective way. Now let's talk about automation. Automation is recently very much changing the way how the dispatch in the mining transportation works. We have real-time monitoring, and automation allows us to monitor equipment and material in a real time by sensors and GPS trackers and so on. We can provide immediate data on vehicle locations, on their operational status, on performance metrics. The visibility enables us to make informed decisions quickly. And for instance, if a vehicle is going in some route and the route's in some way, we can immediately inform the driver, or if the vehicle is driven automatically, then we can put the vehicle on the right way immediately. Automatic scheduling, on the other hand, is an advanced algorithm, and it analyzes the real-time data to dynamically allocate the task in the mining conditions. It can consider variables like equipment availability, maintenance schedules, and production targets to optimize the dispatching decisions. This means that there is less waiting time for the operators and reduced bottlenecks and, of course, a smoother workflow. The benefits of all of this, which I have said before, is the integration of automation reduces the human error. And this is what all of the employees which I have been talking to want to avoid. This is a significant factor in operational inefficiencies and accidents. It improves the response times to unexpected events such as, I don't know, equipment failure or sudden change in demand, and overall automation increase efficiency by ensuring that all of the resources in the mines are used optimally. You can consider a scenario, where an unexpected maintenance issue arises with a critical piece of equipment. The automation can dispatch and reassign tasks, adjust some schedules, and notify relevant personnel to minimize the downtime and keeping the operation running smoothly. The safety enhancement throughout the automation, it's a core value in our industry, especially for Ferrit. We are proud that there were no fatal accidents while using our equipment. We want, through dispatching and automation, even make our equipment safer so the people can feel safe underground, because the work they are doing is quite a dangerous work. All of the dispatch and automation, you can have a hazard detection. You have a lot of advanced monitoring systems equipped with sensors which can detect anomalies and equipment performances or environmental conditions. For example, if there is some overheating in the brakes of some of the LHDs, or the gas levels in underground mines are higher than it should be, this dispatching can stop or adjust the working of all of the equipment, so the risk is getting lower and lower. Of course, the emergency response, you can imagine that time is very valuable when you have some kind of difficult situation in the mine, and automated systems can trigger alarms and initiate emergency protocols and communicate with all of the relevant people or personnel simultaneously. This can save precious time, and it can also avoid for the future for not having any fatal accidents. And of course, if we are talking about autonomous vehicles, there is reduced exposure of people going to hazardous areas. You can have one control room for the whole mine where they are operating all of the fleet of their vehicles. Therefore, the people which are working underground can specialize on different work. By leveraging the automation, we not only protect our employees, but we also try to build a culture of safety. The employees can, after that, work normally and with confidence that around them there are some advanced systems that are in place to monitor and respond to potential risk, and they don't have to care about those things. The last part I wanted to talk about is the future in mining transportation dispatch. And as we look in the future, there are several aspects that are poised to further revolutionize mining transportation and dispatching. Those trends we can see also in other areas, and it's autonomous vehicles. The advent of self-driving trucks and loaders and locomotives is transforming the mining operations. These vehicles, they can work 24 hours a day, 7 days a week, and without any fatigue. They maintain consistent speed and follow optimal routes, increasing the productivity and reducing the operational costs. Artificial intelligence is a thing that AI and machine learning algorithms analyze enormous vast of data to identify patterns and predict outcomes. This enables us to make some predictive maintenance, anticipating equipment failures even before they occur. And this optimizes operational efficiency by adjusting dispatching strategies in real time based on resource availability. Third one is cloud computing. You probably know what cloud computing is, but when we have everything in the cloud platforms, then it offers a scalable data storage and processing power, so we can make really sophisticated analysis for everything which is happening in the mines. We have a lot of data about how the people are operating a lot of their equipment. We have the data about how the equipment is working. We have the pre-effective services and so on. And we can make decisions based on this data. This one will help the effectiveness of the mine working operation, and it's also lowering the hazard for the people. So it means making the safety in the mines better, and also reduces the time when you have to service any vehicle. And a lot of people, considering mine, are speaking about sustainability. And of course, if we have autonomous vehicle, by this one we can lower the consumption of fuel and also lower the emissions which they are producing. They also enables better resource management and reduce waste and environmental impact. So to sum up my presentation, first of all, we have to say that effective dispatching is critical, and it's the cornerstone of operational efficiency and safety. Without it, we risk increased costs, delays, and safety incidents. Or we can say the other way, we are now working in an environment where our delays, costs, and safety incidents are on some level, and if we improve the dispatching of the locomotive, all of these things will improve as well. Automation drives the progress. It's by embracing automation, we enhance our ability to make informed decisions and swiftly optimize resources and protect our workforce underground. And there is one commitment to innovation, because as we will face the future, so we have to integrate advanced dispatching technologies, and we will see what faces us in the future. Thank you for your attention, and I'll give my word to Robert.
Thank you, Hynek. Very interesting, and really nice to see that safety was one of the key outcomes from the automation in the context of responsible mining. Okay, so next up is Jan Kubink from Draslovka.
Good afternoon. It's a great pleasure to be here and show you some innovations which we are working on. In the program, you may see that there should be my colleague Adelbek, but he unfortunately couldn't come. Therefore, I replace him, and I hope that it will be okay. Well, my name is Jan Kubík, and I represent here Draslovka company, which is specialized in the production of chemistry and innovation in mining industry. To begin, I would like to briefly introduce our company and what we are doing. And in the second part of the presentation, I will show you closer one of our technology, Glycat. So, who we are? We are Draslovka, and we are producing chemistry more over than 100 years. Today, we are recognized as a global leader in the research and development of science-based chemistry and innovation in the mining sector. The chemicals which we are produce are used in the wide range of sectors, including mining, agriculture, pharmaceutics, or automotive. With acquisition of Chemours company in 2021, we become one of the largest science chemistry producer on the world. Our global growth continue in 2022 with the acquisition of company Mining and Process Solution, which is based in Australia, and which owns the glycine leaching technology know-how and the patents for the Glycat for the gold leaching and GlyLeach for the leaching of copper, nickel, cobalt, and other metals. This technology was developed over the last 10 years with a partnership with Curtin University in Perth. Well, our complex solution has three main pillars. The first one is a chemistry, which includes the self-production of cyanide and glycinate. It's represented by glycat, which is for gold leaching and other pressure leaching, and glyleach, which is for the copper, nickel, and other base metals leaching. The second pillar is a process measurement, which is represented by our blend Blue Cube. Blue Cube, it's a set of analyzers based on the DRS, diffusion reflective spectroscopy, and these analyzers can provide you real-time information about your minerals and particle size. And the last pillar is an artificial intelligence, which is represented by our brand MetOptima. MetOptima can manage your optimizations and help you to make decisions based on the real-time information from your process. Each of these pillars works great on its own, but when you connect all three, you get a very powerful tool to make your mining operation more effective in all directions. We globally cooperate with the largest gold producers, as is Barrick, Newmont, or Eldorado Gold. And this can serve as a proof of effectiveness of our solutions. That was shortly about our company and what we are doing. And now I would like to take a closer look on one of our technology, glycat. Glycat use glycinate for selective leaching of the base metals, and this enables a significant reduction of cyanide consumption and lower detoxification costs. Maybe you're asking why glycine, or what is the glycine? Glycine is a non-toxic amino acid which is fully biodegradable. You may know it as a food additive or additive to cosmetics. You can usually buy it wherever they sell nutrition supplements, and if you taste it, it has sweet taste. Tastes it much better than cyanide, you can trust me. You may know it from fitness, where it's used as a preparation for growth of your muscles. Yeah. So why glycine? Glycine has a unique ability to selectively leach base metals. And moreover, it's not chemically consumed. So as a primary reagent, it's recoverable and recyclable. Therefore, we use it in glycat, because the glycat is a leaching technology. Sorry, I forgot to switch the slides. Glycat is a leaching technology that combines glycine with lower concentration of sodium cyanide, where the glycine inhibits non-targeted cyanide consumers as a copper, cobalt, or nickel, which you have in your ore, and yeah, it inhibits those non-targeted consumers from the consumption of cyanide, and by that increase the efficiency of sodium cyanide leaching of the gold and other precious metals. Here I can show you some benefits of using glycat. So the main benefits are saving in process costs. especially in the consumption of cyanide and in the elimination or significant reduction of need for detoxification. This results in other benefits, such as a significant reduction in dissolution of arsenic or mercury. Or for some types of specific ores, we are able to increase your metal recovery. In addition, glycat can also reduce your carbon dioxide emissions, or can also reduce arsenic mercury in tailings. Normally here we achieve limits between 20 to 25 ppm. And as you know, it's a half of the ICMC standard. Or lower emissions of hydrogen cyanide gas, which is formed during the gold processing. Standard limits are set to 10 ppm, but with the glycat we are able to easily achieve 5 ppm. On few next slides, I would like to show you some examples from practice. On this slide, you can see aggregated financial data from several mines where we already implemented our technology. So for the reduction costs in the cyanide consumption, we are arranged somewhere between 50 cents to $3 per 1 ton of processed ore. On detox costs, we are able to save you between 20 cents to $3 per processed per ton of one processed ore. Here I can also mention that the glycat is really easily adapted to existing plants because it's used conventional reagent infrastructure. Therefore, minimal capex for implementation is required. On the next two slides, I will show you the examples of two concrete mines where we already implemented our technology. This first slide, you can see the mine which has a big problem with increasing level of copper in their ore, and this extensively increased the consumption of cyanide, which is somewhere between 8 to 12 kilograms per ton. Also, this mine is located in a very eco-sensitive location. So after testing and tuning the entire process for this specific case, we came to the following savings estimates. At this moment, we have a trial test directly on the site, and we think that we should save them $15 million annually on the cyanide consumption and another $5 million on the need for the detoxification. At this concrete case, we also expect the increase in gold recovery. We are convinced that the tests on site confirm these numbers. The last example is from a mine where we already finished the trial test and we see what it really brings. So you can see that we will be able to decrease their OPEX for leaching by 30%. The main thing is that we decrease the consumption of cyanide about 75%, and we also really decrease the costs for the detoxification. Finally, it brings these numbers. It's nice, right? At this moment, we have 37 pilot and pre-piloting projects in the progress, and many others are in the discovery program. how we dial glycate to your site. This process has several stages that involve step-by-step testing and adapting the entire process to your operation. During the entire process, we are closely working together with you and regularly discuss the results of individual tests and the next steps. Maybe you ask how long does it actually take? Well, as you certainly understand, it's not a process that can be done in 1 week. In order to everything work properly, a series of tests must be performed, which require a certain amount of time. Let's say that from the first interviews to the final implementation, it normally takes between 8 to 12 months, depending on concrete case, concrete ore, and other things. Well, thank you for your attention, and I hope that you are interested in this amazing technology. And if you want to know more details, you can feel free to contact us anytime. Thank you.
Thank you, Jan. That was great, really interesting, and great to see that you can get tangible benefits, both environmental and in terms of cost, with a 40% OPEX reduction, obviously significant. Okay, so next up will be Barbara Velikova from the Czech Mining Technology Association.
Good afternoon, ladies and gentlemen. My name is Barbara Velikova, and I am representing here Czech Mining Technology Association. My presentation will not be such technical as we could hear from previous speakers, but I would like to demonstrate you the ability of a group of companies to cooperate in implementation of large projects. We are active in industry sectors such as mining and raw material processing, in energy sector, as well as environmental technologies. Czech Mining Technology Association has been active in Czech Republic for 31 years and currently brings together 18 Czech companies. We have been implementing plenty of projects, not only in the Czech Republic, but also in European countries, in countries of Asia, Africa, or American continents. Thanks to our know-how and mutual cooperation, we provide to our customers turnkey projects, complete solutions for their operations in underground mining, open pit mining, stone quarries, and also in technologies of raw material processing. We provide turnkey projects starting from project planning, feasibility studies, technology design, through the production of machines and equipment, up to assembly of large technological units. On this side, you can see all members of our association. I think I can mention that among them are companies whose beginnings go back more than 100 years, such as company Ostroj, Řetězárna, ZVVZ Group, Sigma Group, or Železárny a drátovny Bohumín. Now, let me for a moment go back in time to the 12th century, when the first when the first records of silver mining in Bohemia were registered. In Middle Ages, mainly gold, silver and tin ores were mined here. And later also mining of glass sands, slate, limestone and granite was developed too. If you are interested in history of mining, you can try to find out books of Georgius Agricola, who described the development of geology and mining in Bohemia in the 16th century. Well, let's go to the current time. Current Czech companies follow the tradition and also very rich and long history. Thanks to many years of experience and also technological sophistication and high level of engineering production, Czech companies have influenced the development of mining during the period of the former Czechoslovakia up to present days. We can talk, for example, about the construction of a complex of coal underground mines in the Ostrava and Karviná coal basin. Our companies participated in design of construction of mine and also in design of entire infrastructure of mine complex. They were major suppliers of technologies, machines and equipment in the stage of construction of mines, as well as later in the stage of extraction and processing of coal. Let's stay for a moment with the underground mining in mines of Ostrava and Karviná region. I think I can mention very briefly a quite interesting project of underground transport optimization in the mine Darkov, where several companies of our association cooperated. Thanks to the logistic process management, automation, and monitoring of transported material and transporting units, the project showed how to achieve significant reductions in operation costs, how to achieve higher profitability of mining production, as well as how to improve mine environment and safety work. Let's go from the underground to the surface, now I would like to introduce you our activities in open pit mining and stone quarries. Our companies have been developed a lot of projects in continuous mining and also in processing of raw materials. For example, in implementation of complete technological lines for crushing and screening. In the energy sector, we are gradually abandoning the production of electricity from coal, and we are moving from black to the green. And with this regard, I would like to mention technologies of association members in the field of environmental technologies and in the field of waste treatment technologies and production of alternative fuels and energy mixtures production for power plants, for cement plants, for heating plants or other industrial operations. In recent years, coal mining activity has been gradually reduced, and the need of post-mining remediation and recultivation has been growing. Our companies participated in many projects mainly in the Ostrava and Karviná region, and provided technologies for old ecological for disposal of old ecological burdens, such as processing of mine dumps, disposal of tailings dams, and waste treatment technologies and recycling. This is one of the projects that was realized in Hermanice for company OKD. This is technological line for disposal of mine dumps, and products of this process are aggregates that are used in construction industry, also tailings for reverse recultivation, and residues of washed coal that is used for energy purposes. Well, we are at the end of my presentation. The goal of the presentation was to provide insight into the work of group companies that can implement huge technological projects. Thank you very much for your attention.
Okay, thank you, Barbara. That's perfect timing to the finish there, and great to see the breadth of projects that the association gets involved with. So now we have 15 minutes left for the panel discussion before there's a coffee break. So I'd just like to open up the session with the first question to the panel, and question will be for Hynek, but it'd be something that it'd be great to see the others comment on as well with respect to their own disciplines. So with respect to your sort of mining transport dispatching, what technologies do you believe will have the most significant impact on mining in, say, the next 5 to 10 years?
I think I've mentioned it already in my presentation, but I think it will be the artificial intelligence, because it will help when we have a lot of data and we have to analyze this data. I think the artificial intelligence can analyze this data like in real time and make the decisions. If we can rely on these decisions, but it can make the decisions in real time, which can very greatly improve the effectiveness and the operations and safety in the underground mines, and it will help also the dispatching. So overall, I would say artificial intelligence will be the most beneficial thing which will help dispatching in the mining transportation.
Yeah, great, Hynek. And I think there's AI it can be fairly application to many industries throughout mining. For example, resource geology as well. AI could dramatically speed up the way that we produce models, or certainly suggest approaches to models, and the efficiency is going to be cost saving, time saving.
I agree with you, and it's saving times, but there is also the second side of artificial intelligence. First of all, we have to know if we can rely on the decisions and so on, but it's in the beginning and of implementing those changes. But it also will, I don't want to say replace, but it will change the way the people work in the underground mines. So you will have a lot of people who will most likely lose their jobs, and you will have to focus on whether these people will still be working for you, and you will have to re-educate them, find new positions for them, or improve them to different positions. So you have to think about this in two ways. Of course, all of the top management and all of the owners, they focus on effectiveness, on profit and efficiency, but there is still need to be some human touch in the underground mines, and you cannot have just the operations in the underground mines solely based on autonomous dispatch and AI and so on. So we have to think about the people, and the other way will be how will you educate those people? What positions or what new jobs will you find for them? And how these people will work with the artificial intelligence? Because the artificial intelligence is most likely higher than all of the populations, and those people who are working in the mines, like directly in the mines, they will have to find some collaboration with AI, and I think that will be quite challenging in the future. So the answer is, okay, AI will be the one who will move us the most forward, but there comes the challenges with AI. But it's overall, it's not only in mining.
There's some very good points there. Thanks, Hinek. So the question, I suppose, extended out to the rest of the panel now as well. Do other people see any sort of differences or have any thoughts with what which technologies will have the most significant changes in industry in the coming 5 to 10 years? But if there's nothing stand out, then it'd be good to open up to a question next from the audience if there's anyone has any questions for our panel. Great. Yeah, I think a microphone's on its way, I think.
I have a question for you, Mr. Okay, so once again, my question to Mr. Baroni about this automatic drilling using your slavery business systems. What's the main obstacle to actually introduce it? I see so many benefits. Like the reduction of labor costs, the safety of labor. What's actually stopping companies mining underground from doing this?
I think in general it's a relatively new technology. So the first implementation not on a testing base but on a regular base has started 4 years ago in Australia and Canada. What is blocking people? I think habits, because in several mines, the managers are used to drill and blast. They live. My father was drilling and blasting. I am drilling and blasting, and my son will also drill and blast. So the changing of approach, and the last point is, especially in the countries when there is a huge number of people working in the mine, the fear that there will be an employee reduction, because anyhow, if we compare. Just a very simple example from Poland. One of the salt mines in Poland is mining 1 million tons, making drill and blast, while the similar mine in US is mining 2 million tons only by continuous miners. And in US there is 40 people. In Poland is 480 people. And this is totally a game changer. And in US, if you raise the question, do you want to come back to drill and blast? No way. No way. And this is just the way how it should work. Other things are, in case of Eastern European conditions, also approach of the mining authorities, which can create additional turbulences to implement. They haven't seen this technology. They want to put additional safety. But at the end of the day, is I would say, willingness of the top management to go forward. In case of state-owned companies, it's a little bit more difficult. In terms of private companies, we're absolutely more willing to change the technology. Again, this is the game changer, no doubts about that.
Great, thank you. Yeah, and a good point touched there on the sort of social responsibility of changes in the industry.
This is a very difficult point. This is a very difficult point because this is not the thing you can make from one day to another. I can give some more examples comparing the similar mines from Eastern Europe to Western world. I'm mainly talking US, South Africa, and we are talking about big numbers. Just one example, to mine 6-7 million tons of coal. In Poland, we need 10 to 15,000 people. In US, it is made by 500 people. So in order to change this responsibility, it is not something which can change during 1 year. It is a long process which needs to be followed and prepared for a couple of years, especially in the area when the mine is the only source of work for several thousand people.
Thanks, some great points. I think we've probably got time for one more question. Are there any more from the audience? Otherwise, I've got perhaps one last question, perhaps to Esko, if that's okay. So you mentioned the P29 technology with increasing efficiency and perhaps replacing froth rotation. I mean, do you see a way that this new technology might be able to help Europe to reduce its dependence on importing critical minerals, and how does it fit into that consideration?
I think that the fastest way would be to increase the production in existing mines. But of course, for all those needed materials, there aren't existing mines in Europe. So the second effect will be then that this would lower the threshold of investments to new greenfield projects because of that energy and water usage and process efficiency increase that the 29 technology is bringing in.
Okay, great, thank you. Okay, so perhaps one last one that I've got on my sheet that we can squeeze in before we go for coffee. And that question is to I wrote it down, but I've lost it in my paperwork, unfortunately. So it might mean we go for coffee a little earlier than I was expecting. Yes, let's not hang on that point, and I think we'll finish up there. So another round of applause for our team, please.